Hello everyone. So today we're going to continue with our lessons on polygons, starting with this first problem. Find the area of pentagon ABCDE given the side lengths and right angles shown. So we have a right angle at C and a right angle at A. Right angles make us think right triangles. So I think the easiest way to approach this problem is to connect B and E, just like that. And now we have a right triangle. And it seems that we have two shapes, a right triangle and a square. So if we find the area of each, then we can find the area of the entire figure. So let's find the area of ABE, our right triangle. Well, that's just 1/2 base times height. So our base would be like the square root of 6. And the height would be the square root of 3. So we have 1/2. Now the square root of 6 times the square root of 3 would be the square root of 18. But another way we could look at it is the square root of 6 is really the square root of 2 times the square root of 3. And we have this extra square root of 3 here. So the square root of 3 times the square root of 3 becomes just regular 3, because when you square a square root, it cancels out. So we're left with a regular 3 times the square root of 2. And to simplify it further, 3 times 1/2 is just 3/2, or 3/2. And then we have our root 3, or root 2, sorry. So that's the area of the triangle ABE. Now we have to find the area of BCDE. So area of BCDE. Well, it looks like a square. The way to confirm that would be to find the length of BE. Now, since BE is the hypotenuse, we can find the length by using Pythagorean theorem, where we take the legs of our triangle squared, and that would equal like our C squared. So the square root of 3 squared is 3, plus the square root of 6 squared, which is 6, equals our C squared. And that becomes 9 equals C squared, which implies that C is equal to 3. Which means that this length BE was our hypotenuse, and we confirm that that has a length of 3. Which means we do have a square since all the sides are the same. Which means that the area is 3 squared, which is 9. So now that we have the area of the two kind of smaller subshapes, we can find the area of the pentagon. So the area of A, B, C, D, E is equal to 9, the area of the square, plus the area of the triangle, which we know is 3/2 times the square root of 2. And that is our answer. So, as always, the key to solving problems like this is to take this relatively complex shape, this pentagon, and break it down into stuff that we know. And once we break it down into a simpler task, or we could say break complicated areas into more manageable pieces, then the problem becomes relatively simple.